Hi. So yesterday we talked about angles made up of rays and line segments. And I know it can get really tricky to be able to see in an angle when you have those different sides, if it's made with a ray or if it's made with a line segment, and then, based off of that, how to name it. So we're going to do a very quick review today. So if we look at this figure, we notice that it has two, I'm going to call them circles on each side, but the technical term is that it has two endpoints. So if this has two endpoints, whereas this figure we see has the two endpoints, but we can see something a little bit different about this figure, and that's that this, where this endpoint is, after it we can see an arrow, and the arrow is our hint that that means it goes on forever and ever in one direction. So because this has two definitive endpoints, no arrow to be found, this tells us that this is a line segment. And we know it's a line segment because there's two endpoints, neither side going in either direction forever. So we're going to label that endpoint. So that being said, because this is a line segment, it has two endpoints, we're going to look again at this figure. And this figure has an endpoint. And we can really actually say that there's two endpoints, but we can tell that past the endpoint here, or the point here, we can see an arrow, which tells us that this is not actually an endpoint. It's just a point in this one side goes on for ever and ever in one direction. That tells us that this figure with one endpoint and an arrow that shows us that it goes on forever and ever in one direction must be a ray. Honestly, looking at them, they look totally similar, but there's that one little difference, is that one side in a ray goes on for ever and ever, and the clue is an arrow. So if you see a point and an arrow on the other side, that's your clue that it's a ray. If you see just two endpoints, no arrows to be seen, that tells us that that's a line segment because there's two endpoints. Okay, so now we're going to look at this angle. This is angle LOP, or we could also call it angle POL, as long as the vertex is the middle letter in either name for the angle. So we want to determine first if this angle is made up of rays or segments. So I see an endpoint here, and I don't see an arrow, so this appears to be like a line segment or array. But there's an endpoint here, which tells us that this is where an endpoint is. And we can also tell that this must be where an endpoint is too, because that's where two rays or line segments meet. So this is going to have two endpoints. I don't see an arrow on either side, not here, not here. And then here, I see the same thing. I see it ending with an endpoint, no arrow going on forever and ever in one direction. And this has to be an endpoint because it's the vertex. It's where the two, in this case, line segments meet. So this is an angle made up of line segments. And let's name the two line segments that make up this angle. So I'm going to change my pen color. One line segment, it's going to be a mess when I draw it, is going to be this one. And when we name a line segment, we start with an endpoint, but they're both endpoints. So this could be segment OL or LO. Either is fine. So now we want to name the other line segment that makes up this particular angle. And we see goes from here to here. So again, because they're both endpoints, it's a line segment that has two endpoints, no arrow in either direction, it doesn't really matter the order that you say the name in. If it were ray, we'd have to say the endpoint first, but it's not, it's a line segment. So this would be segment OP or PO. So the two line segments that make up this particular angle are segment LO or OL, both are endpoints, it's perfectly fine to see them either way, and OP and PO or PO. They're the exact same segment, they just appear in a different order. So either way is a fine way to name them as segments. So now I'm going to show you another angle, and this time we have to determine again if it's made up of line segments or rays. It's a little bit harder to see, so bear with me. So this is angle TAC or CAT. And you can see a little lowercase a here. It's just because I clipped it from the Think Central book. But that's another way to mark that this is angle A. So we want to first determine if this is made of rays or line segments. So let's look. We can see it's made of this and this. And that's where the angle forms the vertex right here at point A. So if I look at this, I know that I see the point here. I don't see any arrow, which tells me that this is an endpoint. And as I follow this, I notice another point, but then I notice an arrow. I'm going to circle, and an arrow tells me that this side is going on forever and ever in the direction that it's headed. Likewise, I notice here, this is definitely an endpoint. There's no arrow. This has to be an endpoint. But by the time I get to point C, I notice that there's an arrow that tells me that this is going on forever and ever one direction. So if it's made up of an endpoint and one side that goes on forever and ever in one direction, that tells me that this is an angle made up of rays. Now, when I name a ray, I have to put the endpoint letter first. So for both of the rays that make up this particular angle, the endpoint happens to be A. So when I'm naming the two rays, they should both start with A. One ray that makes up this angle is ray AT. So we have ray AT, and then remember, whenever we name a ray, we always start with the endpoint. Obviously, the clue here is if it has an arrow, it's not endpoint because it's going on forever and ever, and forever and ever means no end. So this is going to be ray AC. So ray AT and ray AC make up this angle. So now, just to review what we've learned in this video that's now become a long video. A line segment is easy to tell because it has two endpoints. You won't see any arrow on either side. Whereas a ray will have an endpoint, meaning a place where it ends, and then it will have an arrow on one side showing it goes on forever and ever in one direction. Angles can be made of line segments. The vertex is an endpoint, so if you see another endpoint here, it's safe to assume that it's an angle made up of line segments, unless you see an arrow. If you do see an arrow on one side, that tells us that it's an angle made of rays. And when we name the rays that make up that angle, we always start with where the endpoint is. And luckily, they both have the same endpoint, AT for this particular angle and AC. There you have it, friends. Have a great math day.